How are you?
Hi.
Hi. Hi.
Hello.
All the assignments are in My Open Math, I'm assuming?
Yep.
Okay.
Hello. We'll wait a couple minutes. Hello. Let's see how many people we're supposed to have. 13. So with me, there should be 14. How was everybody this morning?
Tired.
Good.
Yeah. Good, good. We'll start in a minute or so. I think we need 2 more people. So what are we missing? So Gavin. And Macy. Okay. Let me just put that in for attendance. Okay. All right, so I'm going to go over the 2 homeworks for today. that are due later, like 8 tonight. So if you haven't started those, there are the videos that you can watch that I made. But if you haven't started those, I can go over those right now. So that's what I plan to do for you guys today. Is everybody ready? All right. So everybody can get on My Open Math, right? We don't have a problem with that? Okay, good. Well, I'm going to present my screen, and I'll just go over the kind of things that your assignments are going to be over. Can you guys all see Desmos? Good. All right, so on the first homework, it's just a review of the transformations that we ended with last semester. So for instance, we did a lot with y equals x squared. We can do a couple of other functions, like a sine function. That's a weird one. And we can even do, I don't know, I'm going to try to make something up. That's a little funky. Let me try something. How about that? So we'll go through what we can do with this stuff using the transformations. So we'll just start with y equals x squared. So if you remember, we had transformations. So we could do shifting it up and down, left and right. We do that by adding or subtracting numbers. And then we can also compress it or stretch it, or we can do reflections. So I'll start with the reflections. The idea here is that if you want to do something vertically, so whether or not you want to shift it up and down, or you want to stretch it up and down, or you want to reflect it, the top and bottom, flip the top and bottom to reflect it, you do it outside of the function. So here, x squared is my function on the right-hand side. So if I add a number outside of it, just off to the side, like +1, I make it go up 1 unit. Or if I do +2, it goes up 1 unit. Whereas if I subtract, like -5, it goes down 5 units. So if I do it outside of the function, it happens vertically. But if I do it inside to the x, to the argument x, so if I put parentheses around x, and then I add in here to the x, so if I say +5, it goes left 5. If I say -2, it goes right 2. So anything you want to do horizontally, you have to do it to the x, to the argument. We call x the argument. Now I'm writing it as y equals this. I think most of your homework problems will have f of x equals, which is, you can think of that as the same as y. It's just function notation. So this is saying that that there's a function which varies with x. So as I plug in different values of x, the function changes. It's just a different notation. I go over this notation more in the video, so if you want to watch the video for homework 1. I described that notation more so. The idea is that a function is an input output type thing. So you input a number, and that's x, whatever x is. You input a number, and then f of x represents the output. So once I put in an x, I get out something else. So like if I put in this case 2, well, 2 minus 2 is 0, 0 squared is 0. So at 2, I would have 0. So the output is 0. And that's shown as the y coordinate. So the x is the input, the y is the output. So maybe I should use f of x, since I think the homework does. But again, if I add something outside of the function, it's a vertical shift. And if I add something inside of the function, like to the x, it's a horizontal. Are you guys okay with that? Does that make sense? Good. Okay, so to reflect it, you introduce a minus sign. You're basically multiplying by -1. That creates a reflection about one of the axes. Again, if I do it outside of the function, so if I do it right here, it's vertical. So I can do a vertical reflection if I put a minus there. Whereas if I do a inside on the x, it will be a horizontal. Now this function is symmetric, so if I do that, you don't see a change. But when I do it to the other functions, you will see a change. But it has technically flipped the left and right side. But because squaring, minus x times minus x makes positive x squared, squaring gets rid of the negative, so you can't really tell. But on the x, it does a horizontal flip, whereas outside of the function, it does a vertical flip. Is that okay? Okay. One thing I'll mention is that if I think the homework will ask you what happens when you do something like this versus something like this. And the way to describe that, like if I do it here, basically every point on the curve, the y coordinate has increased by 2. The x coordinates haven't changed. So like if I just did this point is 0, 0. But if I put +2, it's now 0, 2. And if I did this, I can zoom in and I can see that at this point is 1, 1. But if I do +2, it's now 1, 3. So when I do it out here, all the points have 2 added to the y coordinate. The x coordinate doesn't change. But if I do it here, a cat. Oh, you're here, Macy. Okay. I'll email. I marked you absent, so I'll email the office real quick that you're here. Okay. So yeah, anything you do outside of the function is a vertical shift, and anything you do to inside on the x is a horizontal shift or reflection. And also, if I put I'll do it for the other functions because this one is harder to tell. Any questions so far? Good. Okay, so I'm going to look at this other function. This is a function that we'll eventually work with. We're not going to work with it so much right now, but I just want to show you that this transformation stuff works the same for any function. So again, if I put a +1 outside of the function, everything will go up 1 unit. Whereas if I put a minus, it would go down 1 unit. So again, adding outside is just a vertical shift. If I do it on the x, so if I say +1, it actually goes to the left a little bit. Whereas if I say -1, it goes to the right a little bit. So once again, if I do it to the x, it's horizontal change. And if I do it to the y, it's a vertical. If I do it outside of the function, it's a vertical change. Is that okay? Okay. So these are going to kind of look the same, but if I put a minus on the x, it will flip the function, the left and right. It'll swap the left and right. So it'll be a horizontal flip. So if I put a minus here, it flips around. It kind of turns around left and right. Now this kind of looks the same. This will look the same as what I just did, but it's actually a vertical flip when I put it outside. So if I do a minus here, it's going to take this point and flip it down. So if I put a minus here, it flips it upside down. Whereas if I did it here, it looks the same, but this point would technically move over here, and this point would move over here. So it kind of turns it around that way. Now, one thing I want to show you is, here's a much more complicated function. It has multiple x terms. And this function is a cubic, so it has, it starts high on the right, and then it has this little kink in it, and then it goes down finally. Okay, so if I put parentheses around the whole thing, and I put a minus out front, which if I distribute it, that's the same as changing the sign on every term. But if I put a minus out front, once again, that's a vertical flip. So this thing will flip upside down when I put a minus on everything. So you can see it just went upside down. Here it was originally. You have this small peak and then a larger peak in the negative. But when I put a minus, it flips. So now it's a high peak in the positive here with the small peak now in the negative. So that just flips it upside down. Is that okay? Does that make sense? Now, if I wanted to do a horizontal flip, so if I wanted to make this thing flip around so that this dip was actually on the left side, and then this little peak was on the right side, I would have to go into every x. So let's say, like I said, you have to change the x, but if you have more than one x in your expression, you have to do it to each of them. So if I come in here and I put a minus here, a minus here, and a minus here, that's how I get the horizontal flip. So now the negative dip is no longer on the right, it's now on the left, and the small peak is no longer on the left, it's on the right. If I go back, you'll see it flip around again. So now it's back to normal. But that's how it works with when you have more than one x in your expression. You have to do it to every x, and then you can do the horizontal shift. Likewise, if I want to make this thing go up, let's say I'm going to make it go up 5 units, I could put a +5 here, and everything goes up 5 units. So I've done it off to the side. That does the vertical shift. If I want to do a horizontal shift left and right, I've got to come in on every x. So if I want to shift it 5 units to the left, I'd have to put a +5 here, a +5 here, and a +5 here. And I've just taken this thing and I've shifted it 5 units to the left. But I have to do it to every x. So that's kind of what I wanted to show you. When you have more than one x, you have to do it to every x to get the horizontal thing. Is that okay? Any questions? Okay. Now you may get this as a table. So instead of having a graph, you may have a table. So like, I don't know. Let me make a little Word document. A writer. Well, I can just write. So if you have like a table, let's say here's your table, and you have like 0, 1, 2, 3, 4. And let's say this function is like 6, 4, 2, 0, minus 2. If you have a function, like let's say your function is, y is equal to the function of x. Well, if I put, then they may say, what happens if you have where y is now equal to f of x plus 3, and the 3 is outside of the function. It's just off to the side here. Well, that means all of these units, all of the y coordinates, will get a plus 3. So that'll become a 9, that'll become a 7, a 5, a 3, and a 1. You just shifted the y units. Does that make sense? If I did it to the x, so if I said plus 3 here, onto the x part, not outside of the function, but on the argument, then this will shift me left 3. So this would get a minus 3, minus 3. So you would have the same outputs, but they would occur now to the left 3 units from where they were originally. So the 6 would happen at -3, the 4 would happen at -2, the 2 would happen at -1, the 0 would happen at 0, and the -2 would happen at 1. So you may have questions that ask you in terms of a table rather than a graph, but it works the same. If you do the outside of the function, it's vertical, so it only affects the y coordinates. Whereas if you do it on the x, like here, it will only affect the x coordinates, the horizontal. That's pretty much what I cover in the first video, only I might do it a little bit more so. So if you're having trouble, maybe watch the video. Most of the questions have videos attached to them, so you can click those. I don't know how helpful those will be because I don't create those videos, but that's an option. Also, I don't know that I mentioned these questions on the homework. You have 3 attempts on each question. And if you burn through those, you can click get a new version, and then you'll have 3 more guesses. But that's it. So you have 6 guesses altogether. So what I would say is try them, see if you can figure out what you're doing wrong, try it a couple times. But if you're not getting it, maybe reach out to me and get help before you use your last attempts. There's a limit just because I don't want you guys to just spam guesses and get it right just by guessing, because I want you to know what you're doing, if that makes sense. All right, the second homework that's also due today is over operations with functions. So I'll go over that really quickly, but there's a video that will go over the same stuff. So if you're doing it a little later, you can double check the video. And I'll record this and post this to the YouTube channel as well, so you can rewatch this too. But let's say you have functions. So I have f of x is equal to x minus 1. And I have a g of x is equal to 2x plus 3. Let's say I've got those 2 functions. This second homework assignment, it's not that tough, but there's a few things to go over so that you can do it. Now, they're going to show you things like this. So what is f of x plus g of x? Well, you just add up the 2 expressions. So I would say, well, f of x is x minus 1, and plus g of x is 2x minus 3. So I've got 2 like terms. I've got x's, and I've got constant terms. So that would make 3x minus 4. And that's the sum of those 2 functions. You get a new function that's 3x minus 4. Is that okay? You guys understand that? All right. There's another way that you can write that. It's the same thing. It means the same thing. But instead of writing it like this, they sometimes write it like this, where they put a parentheses f plus g, and then that's a function of x. That means the same thing as adding up the two functions. It looks a little different, but it means the exact same thing. It's just a different notation. So when you see this, it just means add up the functions. So I would do this exact same thing. Is that okay? Are you guys okay with that notation? All right, I'm gonna do slightly different. If you see something like this, f minus g, I'll do that one too. Now you're gonna subtract them. So I'm gonna say x minus 1 for the f. And then the g, I'm subtracting. So I gotta say minus, but it's probably good to use parentheses because that minus needs to affect both terms. It's gonna flip the sign of both terms. You gotta distribute it. So this would actually be x minus 1 minus 2x minus 3. So when you subtract it, you've got to flip the signs of the thing you're subtracting, basically. So this would make minus x, because 1x minus 2x is negative 1x. And then you get minus 4. You know what? I should have had a plus here. This was 2x plus 3, not minus 3. I made a mistake. So this should have been a 2 here. Sorry about that. Little error. But otherwise, it's the same. You add them. You just add up the expressions. You subtract the expressions. Are you guys okay with that? All right. We don't really do division yet. We'll get to that. But there's also multiplication. So you might see it like this, fg of x. That just means f of x times g of x. You're going to multiply them. So you would have x minus 1 and then 2x plus 3. And you're just going to do FOIL, where you do the first, the outside, the inside, and the last, or whatever method you're used to. So I'd get 2x squared. I would get 3x. I would get minus 2x. And I'd get minus 3. And then I could combine the x terms, the like terms. So I could say that ultimately this was 2x squared plus x minus 3. And that's how I would multiply my two functions. Is that okay? The main thing is that you have this slightly different notation. And it just means, like, when I put a plus here, that's the same as what I have up here. It just means add the functions, subtract the functions, or multiply. Now, I'm going to do two other functions. Something like that. Now, they may give you something like this, f times g of 3. So they may give you a specific number. In that case, you can either just multiply the expressions, like so. I'll do 3x squared times x minus 1. And then I have to distribute this in. And I'd get 3x cubed minus 3x squared. And then I could plug in 3. So I could say that x cubed is 27. So I got to do 3 times 27. And then minus 3 times 3 squared is 9. This makes 27. And this makes, is that 81, I think? So then if you subtract those, what is that? 50 something? 56 probably? Let me use my calculator. 81 minus 27. 54, sorry. That's one way you could do it. Otherwise, you could think of f times g of 3 as f of 3 times g of 3. And you can just plug them in directly. So that would be 3 times 3 squared is 27, times 3 minus 1 is 2. So I just plugged in 3 into F and wrote that, and I plugged 3 into G and wrote that. And then 27 times 2 should be 54. Good, it is 54. So either way you want to do those, that works. But they may give you a specific number, and you can just plug it in. Does that make sense? All right, they're going to present things to you also in a slightly different way. So I'll show you those two ways. They might show you a graph of F and a graph of G, or maybe it's like 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And let's say this graph is kind of like that, where this is 1 and this is 2. Maybe this graph is like this, where it's this is 3, this is 2, this is 1. And they may say, well, what's F times G of 2? So when you have a graph instead of an expression, all you got to do is say, well, that's F of 2 times G of 2. So what is F of 2? Well, if I go to 2 on F, that's my input on F, my output is 2, 2, 2. So F of 2 is 2. And G of 2 over here is 1. So it's just 2 times 1, which is 2. So you can use the graph to figure these out when they're asking for the function at a specific number. Are you guys good with that? Questions? Okay. Last type of question. You may have a table. So here's an input, x. Here's the function f of x. And here's the function g of x. So you have a table. And let's say this function is like 3, 1, minus 1, minus 3. And this function is 6, 7, 8, 9, or something like that. And they may say, okay, what is f plus g at 3? So again, that is just f of 3 plus g of 3. And so f of 3, if I look at 3, is negative 3. And then I add to that whatever g at 3 is, which is 9. And so that should give me 6. So you can use the table too. So if you have an expression, you can use the expression. If you have a graph, you can use the graph. And if you have a table, you can use the table. The graph and the table are going to ask about specific values. The expression, they might ask about a specific value, or they might just have an x here where the 3 is. But for the tables in the graph, they're probably going to ask for a specific number input. You guys have any questions on that? All right, that's most of what I cover in the first 2 videos. I just ran through it very quickly. I spent a little bit more time going into it, a little bit more in depth in the videos. So if you need to see those, go ahead and watch those. Again, the homeworks are due tonight at 8 p.m. So see what you can do there. I can give you guys this time to work on the homework if that's what you want to do right now. But if you're not going to do it now, you have to do it later. And again, they're due at 8. Now would be a good time though, because I'll be here for the next half hour or so. So jump back into the Google Meet if you'd have questions. But I'll give you this time to try to get some stuff done. Does that sound good? Okay, sorry for being what you wake up to this morning, but you guys have a great day, and let me know if you need anything. All right. All right. Well, you guys take care, and I will be here if you need me. Did you guys have questions, or are you just going to stay on? Which is fine. I will be right back, though. I'm going to use the restroom really quickly, so just give me a minute. Got my mask. Okay, I'm back. Yeah.
So when it says f minus g and then
Mhm.
x, I don't understand how to do that.
Let me present for a second. So let's say you had like, what is your f of x, I guess?
X squared minus 5x minus 14.
And then what's your g of x?
X minus 7.
All right. So if you have f minus g, so they might write it this way. Or
Yeah,
they
that's
might,
how I wrote it.
that's how they wrote it. Okay.
Yes. Yeah.
So put the f. And then you're going to subtract g. So subtracting basically means you have to put the x minus 7 in, but you got to flip the signs because you're subtracting it. So I'm going to say minus x plus 7. And then you just have to combine your like terms. So here's your x terms and here's your constant terms. You can't do anything with x squared. That's all by itself. Minus 5 and minus 1x will make a minus 6x. And then you've got a minus 14 and a plus 7. I guess that's a minus 7. That's how you would do those.
All right. And then I had the same problem with the multiplication.
Is it the same function?
Yes. Yeah.
All right. So so they'd probably do it like fg of x.
Yes.
So just use parentheses. You can put x squared minus 5x minus 14. And then do parentheses again, x minus 7. Now, to multiply those out, you have 3 terms here on the left and 2 terms here. So you should have 3 times 2 is 6. So you should end up with 6 terms. You're basically going to take everything on the left and multiply it by everything on the right and do that for every term. So x squared times x makes x cubed. X squared times negative 7 makes negative 7x squared. That's good for x squared. Now for minus 5x, you got to multiply it by both of them. So you'll have minus 5x squared. And then plus 35x almost by 7. Handles that term. And then you have the minus 14 times x, so that's minus 14x. Yeah, then then you're going to get negative 14 times negative 7. That'll make a plus 98. Is that right? Yeah. 14 times 7. Yeah, 98. So then you'll just combine your like terms. You've got a couple of x squared terms, and you got a couple of x terms. So like x cubed minus, is that negative 12x squared? Or 13? No, it's 12. And then 35 minus 14 would be 21, I think. 21x. It's not 8. That would be how you multiply them.
Okay.
Does that help?
Yes.
Good. can close that. I guess and stop presenting. No. Yeah. Hi.
Hi, did Gavin ever log on?
No.